Parallelogram law of vector addition. Parallelogram law of vector addition, a law which is used to find resultant of two vectors by graphical method. So we have two vectors P and Q making angle theta with each other, which are to be added or whose resultant is to be found out. Then according to parallelogram law, if you represent these two vectors by two adjacent sides of a parallelogram, then their resultant is given by the diagonal of the parallelogram drawn from the same point. Okay. So we had this derivation, how you derive this parallelogram law, and the final result that we got was this: R is equal to root of p square plus q square plus 2pq cos theta. Remember, we are given two vectors and angle between the two vectors p, q, and theta. Then the resultant is this: R equal to root of p square plus q square plus 2pq cos theta. Magnitude, this is a magnitude of resultant. Okay. Now it is not mandatory or compulsory for you to learn the derivation. The derivation, if you get an idea how what are we doing or how are we deriving the and how we are approaching arriving at the result, that is enough. You need not learn the entire derivation right now. You have to do that later when you go to class 11. So now it is not important for you to learn the derivation. You have to just understand the statement of purpose of parallelogram law first. Then what is its statement? What does it mean? And what is the result that you get from parallelogram law? Okay. Right. So
Sir?
PQ are two vectors making angle theta. The resultant is R equal to root of p square plus q square plus 2pq cos theta. Now continuing from here, I'll take the same parallelogram. This is the vector P. This is vector Q. Angle is theta between these two. And to complete the parallelogram, we draw another vector parallel to P and equal in magnitude. Another vector parallel to Q equal in magnitude. Your parallelogram is formed, and the resultant of these two vectors is given by the diagonal of the parallelogram, which is this. This is the resultant R. And obviously, when you add two vectors, the resultant will also be a vector quantity. Okay. Now, how much is this R? The magnitude of the resultant is p square plus q square plus 2pq cos theta. Okay. Fine. What about the direction? What about the direction? R is the resultant. Okay, fine. Root of p square plus q square 2pq cos theta is the magnitude of the resultant. Okay. From this, you know how much is the resultant. But in what direction is that resultant acting? To know that, we should specify, we should mention the direction of that resultant. Direction of resultant means, as I already told you, we cannot express all directions only by east, west, north, south. There are only four different directions. There are infinite directions. Another way of representing directions in a given plane is by angle. If I take some line as reference and tell you that this particular direction is 45 degree from this line, or 60 degree, or 120 degree, or 180 degree, you can understand the direction. So here we express or we represent the direction of the resultant in terms of angle made by it. We take vector P as the horizontal, okay, and the resultant is making this angle with the horizontal with vector P. Let us say this is alpha, angle alpha. Try to understand the difference between theta and alpha. Theta is angle between P and Q. Alpha is angle between P and R. They are different. So now we can express the direction of R resultant with the help of this angle alpha. How? This was point O, this is A, this is B, and this is C. I will draw a perpendicular from B onto x-axis, this perpendicular. We did the same yesterday also. And let us name this point as D. Okay. If this angle is theta, this angle will be theta. And we got the values of these two sides, AD and BD. AD was how much? Q cos theta. And BD was Q sin theta from yesterday. Okay. Now see, what do we want now? We want the direction of resultant. How can we write the direction of resultant? From triangle OBD, or in short, from triangle OBD. OBD is a right angle triangle. Here it is, this is the right angle. From triangle OBD, I can write tan alpha is the ratio of opposite side in a right angle triangle to adjacent side. So tan alpha is equal to opposite side in the right angle triangle is BD.
Sir, it's in this situation it's theta, na, sir. You wrote alpha.
That's what I was telling you. Theta is a different angle, alpha is a different angle. Theta is angle between vectors P and Q. You need not find that angle, it will be given in the question. We are trying to find the resultant of P and Q, which is R.
Yes,
R
sir.
is a vector. It will have both
Okay.
magnitude and direction. Magnitude is this. What about its direction? Direction of R can be expressed in terms of angle. Which angle? Not theta. R is not making angle theta with P. Angle theta is different. Angle alpha is different. Theta is angle between vector P and vector Q. Alpha is angle between vector R, which is the resultant, and vector P. They are different angles.
Okay, sir.
So from triangle OBD, which is a right angle triangle, if I write tan alpha, which is the ratio of opposite side to adjacent side, opposite side in the triangle is BD for alpha, and adjacent side is OD, which can be written as BD by OA plus AD. OA plus AD. So tan alpha BD is Q sin theta by OA is vector P and AD is vector Q cos theta. Q cos theta. Q sin theta by P plus Q cos theta. This is the from this you can get the direction of R.
Sir,
Oh, yes.
sir, I have a doubt. When we use a when we always use a parallelogram law, we have to draw this red line, sir, to make another triangle.
No, you need not draw.
Beside that parallelogram, sir, Q sin theta. That.
No, We don't draw that parallelogram every time you in the question. You need not draw that line.
Okay, sir.
So tan alpha is equal to q sin theta by p plus q cos theta gives you direction of the resultant. R equal to root of p square plus q square plus 2pq cos theta gives you magnitude of the resultant. This is the direction of resultant. Okay. So finally we have got these two things from parallelogram.
Sir,
The
what is
overall
the
point.
meaning of alpha?
Alpha is a symbol which we use to represent some angle. You can use alpha, you can use beta, you can use A, B, C, D, X, Y, Z, you can use anything. It's just a letter to denote, just like theta, P, Q, R, X, Y, Z.
Sir, that alpha doesn't have a value.
Does theta has any value?
No, sir.
No, sir.
Alpha is a symbol that we are using to represent that particular angle. So instead of writing that this is this angle, every time I cannot write that this is this angle. We are replacing it with some standard symbol, alpha. Right? This what value does alpha has? It depends on the situation, given situation. Alpha can be 20 degree, it can be 30 degree, it can be 60 degree, it can be 90 degree. Right? It does not have a fixed value. Do you understand?
Yes, sir.
So overall, the thing that we have got is if you have two vectors like this, P and Q, which are making angle theta with each other, then their resultant is given by this R, which makes angle alpha with vector P. And magnitude of this resultant is root of p square plus q square plus 2pq cos theta. And its direction is given by tan alpha is equal to p sin theta by p plus q cos theta. These are the two things that you should remember. Need not remember the derivation. I'm again telling you, you need not remember the derivation or learn the derivation that we did yesterday. You should understand it, what is the procedure that we are following. The end result is very important. Formulas, these two formulas are most important. We use these formulas to solve questions related to parallelogram law. Now, see, if we'll take the resultant and we get some important special cases. Case 1. Let us say theta is 0 degree. What is theta? Theta is the angle between two vectors, which you are going to add. If angle between the two vectors is 0, then that means P vector is okay, or if angle theta is 0, then cos 0 is equal to 1. Cos 0 is 1. I hope you remember
Sir.
the standard values of trigonometric
Yes,
ratios,
sir.
sine, cos, tan for 0, 30, 45, 60, 90 degree. Cos 0 is 1. So if cos 0 is 1, what happens to the resultant? Resultant becomes
Root of
R is equal to root of p square plus q square plus 2pq.
2pq.
Cos 0 is 1.
Cos t.
Cos 0 is 1. Or this is like root of p plus q whole square. P square plus q square plus 2pq is like a square plus b square plus 2ab, which is a plus b whole square.
that
So p
roots,
plus
the
q
root
whole.
and squares.
Yes, yes. So square root and square, they cancel each other, and you have p plus q.
Normally.
For r is equal to p plus q. When does this happen? This does not happen every time. This happens only when vector p and vector q are parallel to each other. Parallel to each other means they are pointing in the same direction. Their magnitudes can be anything, but they must be in the same direction. If they are in the same direction, you are simply adding them.
Sir, if they're
If
collinear also, sir.
same
Oh,
direction means collinear also. If they are acting, if two vectors are in same direction, you can simply add them just as how you add ordinary numbers. Only when they are in same direction, not always. So if vector p is 2, vector q is 3, it will be 2 plus 3, 5. Vector p is 7, vector q is 12, it will be 7 plus 12, 19. Like that, you can directly add them. Resultant will be simply the sum of p and q.
sir,
Next, wait, listen to all the cases. Listen to all the cases first. Case 2. If theta is equal to 180 degree, then cos 180 will be minus 1. I think you might not have got this yet in your trigonometry. You'll get it in the coming classes. You know values only up to 0, 30,
sir, no,
45,
sir, no, sir.
60. And
They don't
if you know that, very good. Okay, then it is very good. So cos 180 will be minus 1. Cos 180 is minus 1. Theta, angle between two vectors, is 180 degree. That means the two vectors are anti-parallel to each other. This is vector P and this is vector Q. They are opposite. They are opposite. Then what will be the resultant? If you use the above formula, root of p square plus q square plus 2pq cos theta. Here, root of p square plus q square plus 2pq cos theta. Cos theta is minus 1. So it becomes minus 2pq. Minus 2pq, which can be written as p minus q whole square. Root square cancelled. You get p minus q. Therefore, resultant is p minus q. If two vectors are opposite to each other, the resultant will be their difference. If two vectors are in the same direction and parallel to each other, the resultant will be their sum. Case 3.
Sir,
If theta is 90 degree, then cos 90 is 0. Theta 90 degree means the two vectors are perpendicular to each other. This is vector P, this is vector Q, perpendicular to each other. Then resultant will be root of p square plus q square plus 2pq into 0. Cos 90 is 0. That means root of
P
p
square
square
plus Q
plus square. So resultant of two perpendicular vectors p and q is root of p square plus q square.
Sir,
Yes.
sir, in case 2, how did we know that the vector P is in that direction, Q is in this direction?
Take vector p in this direction, you take vector q in that direction, then also you'll get the same thing. You'll get the difference, that's all.
Then why did you take minus 2PQ, sir?
How much is cos 180?
Cos 180 is minus 1, sir.
Hmm. What is the actual formula? Correct?
Yes, sir.
Is it the same thing that you get here?
Yes, sir.
These are the 3 important cases. Of course, you can do this for theta 30 degree, 45 degree, 60 degree also. But these are the commonly, regularly used cases. Vectors, if they are in the same direction, you simply add them. If they are in opposite direction, you take the difference. Larger vector minus smaller vector. Larger minus smaller. We have already done this. If you remember, if I ask you, 10 Newton force is acting in this direction, 5 Newton force is acting in this direction, what will be the resultant force? Simply, you told this is 5 Newton in this direction. Without your knowledge, you used parallelogram law there. And here, if I ask you, on this body, 10 Newton force is acting in this direction, another 5 Newton force is acting in this direction, then you told resultant force is 15 Newton. There also, without your knowledge, you used parallelogram law. Okay. This is parallelogram law, its mathematical treatment, and what is its purpose. Now coming to the application point, what is the advantage of this parallelogram law? Where do we use it practically? Have we ever seen this parallelogram law? Do we ever use it in our day-to-day life? Yes, it is a very commonly, regularly used law. You might have used it a number of times without your knowledge, or you might have at least seen it happening in day-to-day life. How? Parallelogram law simply says if two vectors are acting on a body, the resultant will be the diagonal of the parallelogram formed by the two vectors. Okay. I think everyone, just a minute, I will take an image.
So done. So done. Sir. So done.
Okay, okay. Is any one of you taking or have taken archery classes?
No,
No one.
sir,
Have you
could you
played
tell
with a bow
that?
and arrow? Have you ever played with a bow and arrow?
Yes, sir.
Or you might have at least seen it in the movies. Bahubali movie, this recently Triple R. Kushal Chandra taken archery classes. Okay, so Kushal has taken archery classes. Then you will be shooting the arrow like this, right? You place the arrow in the bow, you have a string which will be tight. You pull the string back. You place the bow in that attached to the string and pull the string back. When you are pulling the string back, you are actually creating tension in the string. It's just like you pulling a rubber band. When you pull a rubber band, a tension will be developed in the rubber band. Tension is a kind of force. Okay. So due to the force that you are applying by your hand when you are pulling the string back, that force will be developed in the string as tension. And if you take this string, this part of the string, tension will be developed in this string in this direction. Tension is a force, or I'll call force. Okay, I'll call it as force. So force is developed in the string in this part of the string in this direction. And in this part of the string, the other part, a same force is developed in this direction. F. Okay. So now these two forces are acting on the tail of the arrow. This is the tip of the arrow. And this is tail of the arrow which you hold in your fingers. So these two forces are acting simultaneously at the tail of the arrow, which is here. Right. So whenever it is a common point of common sense, whenever force acts on a body, the body moves. If I have this box on the table, and if I push it like this, the box will move in this direction. If I push this box like this, it will move in this direction. So whenever force acts on a body, the body moves. Okay. Now two forces are acting simultaneously on this arrow. One is this force, other is this force. Now if you release your fingers, will the arrow follow this direction or this direction?
It
So
will go
the
straight,
Not
sir.
one, sir.
It will go diagonally.
It will neither go along this direction nor along this
so
direction.
it will
It
so
will go
first
like
go
this.
up, so then it will go down, sir.
The moment you release, not during its journey.
Yes, sir. So it will go like
So it will neither go along the direction of this force nor along the direction of this force, but it will go along this direction. How did this happen? This is nothing but parallelogram. This is nothing but parallelogram law. Force is a vector quantity. Listen completely. First listen completely. Force is a vector quantity. These two vectors are acting simultaneously at this point. Then the resultant of these two vectors must be given by, or it will always be along the diagonal of the parallelogram. Where is the parallelogram here? If you imagine a parallelogram, this is one side, this arrow, this string, this string is one side of the parallelogram. This string is the other side of the parallelogram. And these two sides are making angle theta with each other. Then you can complete the parallelogram by imagining pairs of opposite sides like this. This is your parallelogram. The name, if you give the same names as we have given there, then this is your point O, this is A, this is B, this is C, this is your vector P, this is your vector Q in our derivation, making angle theta with each other. Then the resultant of these two vectors is given by the diagonal of the parallelogram, which is this R. That's why the arrow follows this path. One situation. Another situation. Suppose I'll take another picture. You might have used this catapult. Catapult also works on the same principle. You will be having a rubber strip. Catapult, yes, it is like this. This is a catapult. You have two rubber strings. You hold something, some stone or marble here, and pull it back. Thereby, you are creating tension in the string. This is one tension. This is one tension. And when you leave the marble or that stone, it follows this path, which is again the resultant diagonal of the two sides, diagonal of the parallelogram formed by those two vectors. Or if you take rowing of a boat, you have what you call that paddle. Two paddles on two sides, and you row the boat with that like this. Yes, these two things at the side, these are called paddles. So to row the boat, you should pull these paddles so that they go like this. This paddle goes like this. This paddle goes like this. Okay. And as a result, what happens is you are pushing the water with these paddles. If you push something, that thing also pushes you. Newton's third law. Every action has equal and opposite reaction. So the paddle the water will be pushing the paddle in this direction and here in this direction. If I displace these two vectors and place them here, we can displace a vector parallel to itself like this and like this. Then the resultant of these two vectors will be this thing. And this is the direction in which your boat goes. Flying of birds. When birds fly, they push air back with their feathers, with their wings, and air pushes them forward. It happens in the same way. So flying of birds. Like this, when a bird moves its wings, it is pushing the air in backward direction actually. It is pushing the air in backward direction. This and this. As a result, air pushes it exactly in the opposite direction. This and this. These two are two sides of the parallelogram. Resultant of these two is given by this. And this is the direction in which the bird goes. Like this. So all these things that we see in our daily life, they are nothing but applications or examples of parallelogram law, where two vectors acting simultaneously at a point give resultant depending upon their magnitudes and their direction. Okay. Any questions? Right, this is about practical examples. Now, if you come back to the mathematical part, how, suppose I give you a question like this. And before this, you should remember the formula of parallelogram, like how you remember a plus b whole square. You can never tell the formula of a plus b whole square wrong, right? In the same way, you should never be wrong with the formula for parallelogram. Resultant of two vectors, r is equal to root of p square plus q square plus 2pq cos theta. What is p, what is q, what is theta? PQ are two vectors whose resultant is to be found out. What is theta? Theta is angle between those two vectors. Okay. So if a question is given like this, two forces (6 Newton and 8 Newton) are acting on a body, Find their resultant if angle between them is number 1 0 degree, one 80 degree, 90 degree, 30 degree, 45 degree, 60 degree, 120 degree. I will do only 2, the rest you should do. So we have two forces, 6 Newton and 8 Newton, acting on a body at the same time, and we should find the resultant in different cases when they are making different angles with each other. First of all, they are making 0 degree angle with each other. That means the two forces are like this. This is, I will represent 6 Newton with vector P, and 8 Newton with vector Q. 6 Newton, 8 Newton are making 0 degree angle with each other. Theta equal to 0 degree. P is equal to 6 Newton. Q is equal to 8 Newton. The resultant of these two, root of p square plus q square plus 2pq cos theta, root of 6 square plus 8 square plus 2 into 6 into 8 into cos 0, root of 36 plus 64 plus 2 6 12, 12 8s, 96, 36, okay, 64, okay, 96 cos 0 1. So this is 36 plus 64, which is 100 plus 96,
196
which
root
is
14.
root, which is 14 Newton. 14 Newton, or If you have understood those special cases, you could have directly told that resultant is P plus Q. This is like case 1. If two vectors are parallel to each other, you can simply add them without the need of applying the formula, substitutions, all these things. You can simply do P plus Q, 6 plus 8, which is 14. Second, theta is equal to 180 degree. That means the two vectors are like this. Vector P is 6 Newton, vector Q is 8 Newton, and they are opposite to each other. If they are opposite to each other, I will not apply the formula there. I will simply write R is equal to P minus Q. P minus Q here in the sense larger vector minus smaller vector. Larger vector is 8 Newton, smaller vector is 6 Newton. So the resultant of these two will be 2 Newton along this direction, along the direction of Q. So R is equal to P minus Q, or I will write it like P difference Q. Difference. This is the symbol for difference, which is 8 minus 6, which is 2 Newton. Direction will always be along the larger vector. Okay. Third case, theta is 90 degree. The two vectors are perpendicular to each other. This is P.
Sir,
6
answer will
Newton.
be root.
This is 8 Newton. So here, parallelogram law gives you R is equal to root of P square plus Q square plus 2PQ
Answer is 10.
cos 90 cos theta. If I substitute values 1 by 1, 6 square plus 8 square plus 2 into 6 into 8 into cos 90 root of 36 plus 64 plus 96 into 0, which is root of 36 plus 64, which is root 100,
10, sir.
which is 10 Newton. From this, you should understand one very important point, which you should learn from vectors. What are we doing here? Basically, we are adding 6 Newton and 8 Newton. We are adding 6 Newton and 8 Newton. If these two were scalar quantities, if this were scalar addition, the result will always be 14 Newton. But as they have directions, they are different quantities. They don't have just magnitudes. They have direction also. If direction changes, their resultant changes. That's why one time you are getting 14 Newton, other time another situation you are getting 2 Newton. In another situation you are getting 10 Newton. In another situation you might get 7 Newton. Another situation you might get 1 Newton. Another situation you might get 12 Newton. So you can get values which lie between 6 plus 8 and 8 plus 6 and 8 minus 6. 8 plus 6 is 14, 8 minus 6 is 2. So the resultant of these two vectors can have any value between 2 and 14, depending
That much only, sir.
on value of theta. For different values of theta, you can get 3, 4, 5, 6, 7, 14. You cannot get any value greater than 14. You cannot get any value less than 2.
Sir,
Yes.
when the theta's value is 180, we have to take the vectors as only in opposite direction, sir.
Yes.
Okay, sir.
Sir,
Yes.
sir, that means you gave one formula, no, sir, for theta is equal to 0, resultant. R is equal to root over P plus Q.
R equal to P plus Q, that's all, for 0.
Yes, sir. But why didn't we use it in this, sir?
If I had done that, I think most of the questions students would have not understood that. So I did it in the regular method.
Okay, sir.
Okay, these are the three things you should do for the other four: 30 degree, 45 degree, 60 degree, and 120 degree. That is homework for you. Right. This is parallelogram law. And tomorrow we will do some more questions based on this.
Sir, can you please stop the recording?
Madam?
Sir, can you please stop the recording?
Okay, okay.